Are you ready, everyone? Use your quick reaction. Right, thank you. Kaushik, Rohit, Vikrant. Right, everyone ready? So just look at yesterday's discussion about activity 2 using the sunlight. Just we got the image on the paper, right? So here simply it helps us to find out the focal length of a concave mirror. For this we are using the operators, that means materials, concave mirror, a sheet of paper, scale to measure the distance between the pole and the image obtained on the paper. So just look at them here in the procedure. Just I am taking and exposing the concave mirror towards the sun. Then here simply you have to know the center of curvature. Actually it is not visible to you in front of the mirror, just it is imagination. At what distance its center of curvature will be located, that I am showing you for your understanding purpose. Then pole identification on the mirror, then joining them with a straight line that which passes through the pole and center of curvature called as principal axis. Then now we are having a sunlight in front of the mirror, that we are focusing onto the mirror. From the sun you are going to receive the parallel beam of light rays, that which is focused on the mirror. So what happens here, that light rays all are going to be focused at a common point, that which is located on the principal axis. So here all the light rays are going to be converged at a common point, that which lie on the principal axis, right? So here that point we can call it as focus here, right? This point is called as here focus, denoted by the letter F, right? So this is we got actually by the converging of reflected light rays, right? So the point which we obtained by the converging point of reflected light rays is called as focus or focal point. So then the distance between them is called as, between pole and the focus, that distance we are calling as here focal length. So this distance you are measuring with the help of scale. So here what to do actually, here you have to place a paper to obtain the image of the sun at this spot. So here what happens, if you keep the paper for some time at this focus, here the paper starts burning, right? So this distance you have to measure at what place you are obtaining the sharp or a bright spot of light. That point only we can call it as focus. So that distance you are measuring, right? So that we can define as focus or focal point. Then at that place here you are measuring the distance from the pole, right? So everyone is clear about this activity. Use your quick reaction, right? So read this information which is given in the page number 4, activity 2 in your textbook, right? So now we'll go for another topic, that simply what we discussed in the activity 2, that we are trying to obtain a diagram using geometry knowledge, right? So for that, what I am doing here, I am drawing a straight line on the horizontal paper as you see here, then identifying a point on the line just towards right side, identifying that as center of curvature. Then using the compass, I am just drawing a arc, cutting the arc as you see here, then make it as a concave mirror, shading its convex surface with small lines called as opaque surface. Then what is its reflecting surface? Concave surface. So this mirror is what? Concave mirror. Then here, now I am showing you the point on the curvature, midpoint. That point I am calling as here pole. Then what to do? Simply here, you have to incident a parallel beam of light rays on the concave mirror. So how these rays are parallel to each other, right? These rays are parallel to each other as well as parallel to the principal axis. Themselves parallel and they are parallel to the principal axis. Is there any confusion? Is there any confusion? All the light rays which are incident on the surface, they are parallel and they are also together parallel to the principal axis, right? So if there is any confusion, raise your hand. Then I am showing you the reflected light rays. So here I shown only one ray. Why? Without going to measure the angle of incidence and angle of reflection. Anybody? Because it is along the principal axis. So here it is not making any angle with the normal. Principal axis also known as one of the normal. It is nothing but normal at pole. This line will be act as a normal at pole because it is connecting the center of curvature and the boundary. So nothing but this distance we can call it as radius of curvature. So it is also known as radian, right? So that's why here I didn't show the angles. Then for the remaining rays, that means these. For these rays, I'm going to show you normals, right? So these are what normals. So here I completed a reflected light ray. How can I complete? By measuring the angle of incidence for the first ray, and I will measure the angle of reflection R1 for the first ray. So here what I know, angle I1 is equals to angle R1. Why? Here it is law of reflection, right? Angle I1, that means angle of incidence, is always equal to angle of reflection, that is R1. So using that logic, I am completing all the light rays behavior. Is it clear? Is it clear? So second ray, I am drawing the normal. From that place, I will measure second ray, I2 angle, then R2 angle, complete that reflected ray. Then go for the third one. Complete the reflected ray by measuring angle of incidence and angle of reflection. Go for the fourth ray. Draw the normal, then measure the angle of incidence, recognize as I4, then measure the same angle that is equal to angle of incidence I4 as identified here R4, then completing the reflected light ray. So now look at where they are after reflection. That means I am asking, they are going to meet at a common point or not? Anybody? Are they going to meet each other? No one responding. After reflection, I am asking, after reflection from the mirror surface, do they meet?
Yes, sir.
Yes. So here that common point, right, where they are going to meet, that point, where is available? That point lie
on the principal axis.
On the principal axis, right? So that point is what here? So I am identifying that point. So blue color spot is shown here. So that point is what for us? That point is what for us? Or less converging point, right? That point is what? Converging point. So this converging point is called as what? focus, denoted by the letter capital F. Is it clear, everyone? Is it clear? So geometrically, we can represent the activity 2 as like this by the diagram, right? So you can use the protractor to measure the angle of incidence at any point and measure the same angle with the protractor another side to the normal. Look at always angle of incidence and angle of reflection are opposite sides to the normal. So here look at angle of reflection. This is angle of incidence. Both are opposite sides to the normal. Rendu same side undavu gurtu pettukondi. Suppose if the angle of incidence above the normal, angle of reflection will be below the normal for any mirror. Is it clear? Quick reaction. Is it clear? Right. So now we will go for another here only. So look at here. I got converging point. That converging point will be called as now focus. Right. So now what I am doing here, from the pole, I am drawing a line. So here these pink color lines are parallel to each other. Yes or no? That pink color lines are parallel to each other. That gap is shown by the straight line. Red color spot here. This is line, right? So this gap I am defining as focal length. That gap is what? The length between the pole and focus. The length between the pole and focus. This length is defined as focal length. The length between the pole and focus or focal point is called as focal length and denoted by the letter capital F. So here one more you need to learn. So I'm going to clear all this information what I am written. Right? Up to here is clear? Everyone, is it clear? Right. So now I'll give you another point here. So I am taking one more line from the center of curvature here. Right. That is also parallel to the pink color line, what is drawn from the pole. Right. Now what I am doing here, I am measuring the gap between pole and the center of curvature. Can anybody say what that length measures actually? What this length measured?
Radius.
Radius of curvature.
Very good. It is what? Capital R, called as radius of curvature. Right? Radius of curvature. So here we have a relation between R and F. So which is smaller here, R or F?
F.
F is smaller, right? So always F is smaller than R. Then we have a relation between R and F. That is F is half of the radius, or R is double to the focus. R is double to the focus. Okay. So we have proof also, but it is not available in our textbook. That is explanation given in the CBSE syllabus, right? So that link I will share you in the WhatsApp. I will upload the YouTube video which is created by me for your understanding. No requirement of that proof, no need to learn that proof, but for your understanding, I will give you that proof as video in the WhatsApp, and also I will upload that in the app. Okay. So this relation proof I'll give you. Okay. So is it clear? So you need to remember the relation between R and F. Radius of curvature and focal length relation. What is that relation? Radius of curvature is double to the focus. Radius of curvature is double to the focus. Clear? If I ask you clear, just go for the quick reaction, right? So this is the topic which is given in the activity 2. So after that, one question is asked in the page number 5. What is that? Can you draw the same diagram for a convex mirror? So here, one more I need to mention here. That is simply here where the converging point of reflected light rays is available. Converging point of reflecting light rays. Is it before the mirror or behind the mirror? That point is available in front of the mirror or behind the mirror? Anyone? Unmute and answer. Where the converging point is located, is it in front of the concave mirror or behind the concave mirror?
Behind the concave.
See again.
Before.
Very good. It is before. See here, it is reflecting surface, right? Towards the reflecting surface only this point is available. Yes or no? Right? So simply reflecting surface side only, you have the point, converging point, right? Converging point is available in front of the mirror. Yes. So if you get any meeting point, converging point after reflection in front of the mirror, that will give you real image, right? That will give you real image. If any image is formed by the actual rays converging point, right? If you get any point by the actual rays, that will give you real image. What is actually real image? Real image means simply the image which is formed on the screen. Formed on the screen, right? So that image is called as real image. I will show you that image in the lab activity. Okay, while explaining the lab activity, I will show you what is real image. Okay, on the screen, we will obtain the image. For example, where you can see yourself daily after fresh up. Anyone?
Mirror.
Tejaswini. Where you can see your face.
On the mirror.
Right. On the mirror. Suppose if you go to a theater, where you can see the movie? Anyone?
On the
Screen.
screen.
On a screen.
Very good. On the screen. Actually, it is a cloth. Do you know that?
Yes, sir.
It is a cloth, white cloth. So projecting the light onto that from a distance, right? So what you can see on the screen, right? What you can see on the screen, that image is called a real image. So playing a movie on the screen is what? Real image, right? Watching anything on the screen is called real image. Okay. So virtual image is what? On the surface. Virtual image is on the surface. On the mirror, for example, what you experience. Is it clear? So you got the meaning for the real image and virtual image. We can view the image on the screen, that we can call it as real image. What you can view the image on the surface of the showing body, right? That is called virtual image. So this is the topic we have to learn in this case, right? Now the question is asked in the page number 5 of your textbook is, can you draw the same diagram for a convex mirror? So now we'll go for that topic. So I am taking the convex mirror now, right? So for that also I am taking the center of curvature, but quite opposite is taken. Look at here. For concave mirror, I taken center of curvature right side. For the convex mirror, I am taking center of curvature at left side. Right? Then I am cutting an arc, not exactly to the right end, just in the middle of the paper, as you see here. Why? Because I need just some space in front of the reflecting surface. Now, anybody tell me which surface is reflecting surface now? Right surface or left surface? Anyone?
Right surface.
Right.
Right surface. Why you choose a right surface? What you require here? I need convex mirror. So why you choose a right surface as reflecting surface? To
The
make
reflecting surface is convex surface.
we required here to make a convex mirror, convex surface as reflecting surface, right? So now shading the concave surface. Is it clear? So now the mirror is
Convex mirror.
convex mirror, right? Now the mirror is convex mirror. Next, identifying its pole. So for this also, geometrically midpoint on the curvature. That is only here pole. So no difference, right? Then what to do? We have to choose parallel beam of light rays to target on the mirror, right? So what about this middle ray that is along the principal axis? After reflection, where it will be?
Sir, same path.
Why same path?
Sir, it remains undeviated.
No, deviate not. Deviate we will use in the refraction. It retraces its path because there is no angle made with the normal. Here, angle of incidence is 0 and also angle of reflection 0. So it remains along with the same line, retrace its path, right? So here I am drawing the normals to the point of incidence, right? So normal is what? What is normal actually for the curvature or curved surface? Anybody raise your hand to say the answer? Don't unmute, raise your hand and say clearly answer. No one? No one raised your hand. Right. So here see simply the line which is joining the center of curvature and the point of incidence. Is it clear? The line which is passing through the center of curvature and the point of incidence, that we can call it as normal. Normals, as many as you can draw, infinity, right? So that we can call it as normal. So normal drawn. Then what to do? We have to measure the angle of incidence in each case, for the first ray, for the second ray, for the fourth ray, because third is 0. Then fifth ray is I5. Then what to do? After measuring the I1, I2, I3, I4, what to do? Measure the angle of reflection. R1, R2, R3, sorry, R4, because R3 here already completed. Then R5. See, sorry, I made a mistake here. Right. On the opposite side, right? Always opposite side to the normal. So it is R5. No, R4. Is it clear, everyone? What I am written on the screen now? For measuring purpose, I am given. Okay. Next, what to do? Complete the reflected light rays after identifying the angle of reflections respectively to the reflected light rays. So now I am completing. So R3 is completed first because it retrace its path. Then next, see here, R1, ray 1 is completed. Next to second ray, third ray, sorry, fourth ray. Next, fifth ray. Is it clear, everyone? Give me your response. Any confusion? Just raise your hand. If nothing, we will go for completion of this one. Okay. So here, I drawn reflected light rays after incident on the convex surface, on the convex mirror. So what happens? Do they meet each other after reflection?
No.
Do they meet?
No, sir.
No, they never meet for any extension in front of the mirror. I'm clear? Any confusion? Do they meet? No. So in this case, what we'll say, they appear to
Diverging.
diverge. So separating, the distance is increasing if you extend them, right? So they are said to be diverging light rays. Is it clear? Diverging light rays. So now what I am doing here, I will go in the backward direction. See here. I'll go in the backward direction. So what happens if I go in the backward direction? Using the reflected light ray, I am extending using the dotted lines in the same line in the backward direction behind the mirror. What do you notice here? What do you notice? Anyone?
They meet at a point.
Right. So they appear to meet. Actually, they cannot meet. They appear to meet. So here, what I am saying, they appear to diverge from this point. Right? They appear to diverge from this point. Yes or no? అన్ని ఆ పాయింట్ నుంచి పోతున్నట్టు కనబడుతున్నాయా లేదా అదే అడుగుతున్నాను. ఎనీవన్?
Yes, sir.
Yes. So I am now identifying this point as what point? Diverging point. Okay. So this point is called as diverging point. Now I shown two parallel lines using pink color. Right? So now I will measure that distance between them. So pole to the diverging point. Pole to the diverging point. What we can call that distance? Anyone?
Focal length.
Focal length. So pole to the focus. So which point is acting like a focus for the convex mirror? Which point is acting like a focus for the convex mirror? Anybody?
Diverging point.
Very good. For the convex mirror, diverging point is acting like a focus for the convex mirror. For concave mirror,
Converging point.
very good. So for a concave mirror, what point we have? Converging point, right? For the convex mirror, diverging point. So this converging point or diverging point only act as focus for the respective mirror. So which mirror has converging point after reflection with the parallel beam of light rays? Are you following? Or any confusion? Very good. So here, for which mirror you have the converging point with the parallel beam of light rays after reflection, that mirror called as converging mirror. So which mirror is called as converging mirror? Answer my question.
Concave.
Concave mirror.
So what about the mirror you see on the screen called as?
Diverging mirror.
Which mirror is this?
Convex mirror.
So convex mirror is called as diverging mirror. Concave mirror is called as converging mirror. Is it clear? So I given you two different names for the concave and convex mirrors. Yes or no? So concave mirror is converging mirror, convex mirror is diverging mirror, right? So the length between the pole and the focus is called as focal length. No change in the terminology. But what you need to identify. So here, center of curvature and the focus is behind the mirror. They are behind the mirror. For which mirror?
Convex mirror.
For convex mirror. For a convex mirror, F and C are behind the mirror. Is it clear? Yes. So center of curvature and focus both are located behind the mirror for a convex mirror. What about concave mirror? 7. Where the center of curvature and radius of curvatures for concave mirror?
Before the mirror.
Okay. For a concave mirror, C and F are before or in front of the mirror. Are you clear, everyone? Any confusion? So where they are available, there only you can measure the radius of curvature and center of curvature. Focal length. So F and R we can measure behind the mirror for a convex mirror, right? F and R we will measure in front of the mirror for a concave mirror. Clear? Use your quick reaction. F and R we will measure in front of the mirror for a concave mirror. F and R we will measure behind the mirror for a convex mirror. I think no confusion, right? So we will end this session and immediately we will start another, because this time is going to end. Immediately join using the same link, right? Immediately join. I am ending this session for now. Immediately join for the next one, right?